Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at dividing by a non-linear polynomial. So here we're dividing a cubic by a quadratic. Turns out we do it exactly the same as when we were dividing by a linear factor. So we take our x squared plus 2 and we want to see how it goes into our cubic. So I start as always by having leading term divide leading term. So x cubed divide x squared is just x. So whenever I get something up here, multiply it by the polynomial by which we're dividing. So x times x squared. Now x times 2 is 2x. I'll put that under the x. I didn't get any x squareds, but I still need to write this in. So now I'm going to calculate the remainder by subtracting. Of course, x cubed minus x cubed is 0. 4x squared minus 0x squared, well, that's just 4x squared. Negative 5x subtract 2x is negative 7x. So the problem is, if I multiply x by x squared plus 2, I didn't get any x squareds, I wanted 4. So 4x squared, leading term divide leading term, that gives us plus 4. So we need the plus 4 because when I go 4 times x squared, I get 4x squared. That's what I wanted. But 4 times 2 gives us 8. That's not what I wanted. So we needed to have here a plus 2. We also didn't get any x's. So now we're going to subtract. So negative 7x minus 0 is negative 7x, and 2 subtract 8 is negative 6. So this here is our remainder. We haven't any space to write more terms there. So we've found that the cubic, I'll call that f of x, we can write that as x plus 4 times x squared plus 2. But there's going to be a remainder of negative 7x minus 6. So when you're dividing by a quadratic, the remainder could be 0, it could be a constant, but it can also be a linear function. So what is the actual answer to this division here? Well, we found that we have x plus 4, but the remainder was negative 7x minus 6. So we write that remainder over the polynomial by which we divided. See, that's the same as if you have 37 over 5, you get 7, the remainder's 2, and it goes over what you were dividing by in the first place. All right, let's now look at another question. So let's determine if this polynomial is a factor of this one. We looked at determining whether or not a linear polynomial was a factor and saw that it's a factor when and only when they have the same roots. It's the same principle here. Now, x squared minus x minus 6, we can factorize that as x minus 3, x plus 2. The roots of this polynomial are just positive 3 and negative 2. So it will be a factor of this if and only if this has roots 3 and negative 2 also. So it turns out f of negative 2, if you substitute x for negative 2 here, you get 0. So negative 2 is a root of fx. But if you substitute x for 3, I think you get negative 47. So 3 was a root of this polynomial, but it was not a root of this polynomial. So because of that, this is not a factor of this one here. The answer is no. They both have a common factor of x plus 2, but because this one has a root that is not a root of this, it isn't a factor. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.